Hi guys, we're going to be starting the trickier portion of this lesson. It's on the area of segments. First we're going to go over what a segment is and then how to find the area of it. So just straight definition here, a segment is a segment of a circle is the part of a circle bounded by an arc and the segment joining its endpoints. Okay, so this is what it means. We're going to go back to something we already know. We know secant. We know this is going to be here. That would be the area of a secant, okay? Now, if I drew a line and connected this point and this point, we're going to get a line that goes right here, okay? So that creates a triangle inside of here. Now, if you look at the areas, the secant here, if I took this triangle and overlapped it here, it's covering all of here. But if I subtracted this triangle off from here, you're left with just the little arc in there, which is what we're going to be talking about today, which is the segment area. So it's just this little area, and it's between the arc and the segment joining the two endpoints, okay? So that's pretty much the formula for it. It's secant area minus triangle area is equal to segment area. A little bit of a breakdown of those formulas. Secant area, we know this is the area one, which is why we're doing theta times pi r squared, because that's the formula for area, divided by 360. Triangle area, we're back to just a basic area formula. Area is equal to 1/2 base times height. That's going to be equal to the segment area. So what we're going to do, and this is why I have it listed as 1, 2, 3. This is going to be longer questions. We're going to do part 1, find this. Part 2, find this. Part 3, find this. 1 and 3 are very easy. 2 is deceptively tricky, okay? Nothing that you can't handle, but definitely a little bit trickier. Before we actually go into that, I want to go through 3 things that we just have to remember from already previously learned knowledge. So, 3 things to remember. Number 1, 30, 60, 90 triangles. It hasn't been that long since we've done them, so hopefully that's still in your memories. We have 2 formulas for that. First one is hypotenuse equals 2 times short. Second one is longer equals square root of 3 times short. Just to remember this, we have short is across from 30, longer is across from 60, and hypotenuse is always across from 90. I would have this written down somewhere. Probably not on your notes. There's going to be a lot of writing you're going to have there, so maybe a separate sheet of paper. The next one is 45, 45, 90. It's just one formula. Reason why is because the 2 legs are congruent, and it's hypotenuse equals square root of 2 times leg. The last thing is our SOHCAHTOA. So yet again, we can use that for our right triangles. SOHCAHTOA is sine, cosine, tangent. You're going to have it where you're going to have 2 missing variables and 1 given value. So for example, this one gives you the hypotenuse. I would put x and y. Given the angle that you're going with, here would be opposite, this would be adjacent, and this would be hypotenuse. I would then say, okay, let's say I just want to solve for x right now. I'm going to use the angle, x, and the 10. So I'd say, okay, opposite hypotenuse, that's O. So it's so. So it's sine of the degree, 50 equals so. So it's O over h, so it's x over 10. At that point, how do you solve it? Well, I'd multiply each side by 10, and I'd get 10 times the sine of 50 equals x. Just throw that into your Desmos scientific calculator or your actual calculator if you have one at home, and you get your answer. Okay guys, we're going to go on to the actual practice problems. So what we have here is number 19. It says find the area of the shaded region. I look, that's going to be a segment. So we're going to find the area of the segment. So I have 3 steps, starting with finding the sector area, so the full area there. That's going to be the easiest part of this. So I'm going to start out with step 1, and this is sector area. I'm going to look for the degree. So here it's 60 times pi r squared. So pi 8 squared over 360. And we're going to put that in our calculators. We end up getting 3,840 pi over 360, which is equal to 33.51. You really only are going to be working with the decimal form, so this doesn't really matter to us. We don't need to be simplifying it. We just really need the decimal. So I'm done step 1. I'm moving on to step 2. Now step 2 is the long and hard part of this whole process. So bear with me. What we have is we're going to be looking for the triangle area. Now I know it's 1/2 base times height, but we're going to be using a weird part of it. So what's going to happen is we're going to take this and we're going to draw perpendicular bisector down. Okay? This part here is going to be my base. This part is going to be my height. Okay? So I'm just going to leave this right over here. So what I mean is this is the base, this is the height. And we're going to be able to find those lengths by either using 30, 60, 90, 45, 45, 90, or SOHCAHTOA. So what I have here is I'm going to draw out this triangle. Okay? I'm going to split it with the perpendicular bisector with the right angle there. This part here is right out there, so these are 8. If this whole thing is 60 and it's bisecting that angle, each of them is going to be 30 because I cut it in half. To make this a little bit easier, I'm going to just focus on the left portion of this triangle the whole time. So I mean this part right now, that's what I'm focusing on, okay? So if this is 30 and that's 90, this has to be a 30, 60, 90 triangle. So I'm going to go back and use my rules for 30, 60, 90 triangles. So I have hypotenuse equals 2 times short and longer equals square root of 3 times short. I'm gonna actually redraw this right underneath. I know, a lot of redrawing. So I'm gonna redraw this. I have 90, 30, 60, 8. I'm gonna put X and Y here. If you can tell, over here would be X, here would be Y. We want those lengths. So let me label this 30 is going to be my short, across from that 30, across from the 60 is going to be my longer, and across from the 90 is going to be my hypotenuse. You see which one you actually have. So in this case, we have the hypotenuse. So I'm going to start with the equation that has to do with the hypotenuse. So I have hypotenuse equals 2 times short. I fill in, my hypotenuse is 8, equals 2 times short is going to be X. Solve it by dividing by 2. I get 4 equals X. Put it here. So this is 4. So I'm actually going to go up to here and put 4 in here. Now because this was a perpendicular bisector, if this is 4, this is also 4. Making this whole thing 8. I'm going to go over to the base. My base is 8. Let's go down and find the longer because that'll help me with my height. So I'm going to use longer equals square root of 3 times short. Longer is going to be Y equals square root of 3 times short is 4. I'm just going to rewrite that as 4 root 3. And I'm going to put it right up there because that's exactly where it was for me. So this is 4 root 3, 4 root 3. Okay, so that is us pretty much done the triangle. I just have to plug in now. So I have area equals 1/2 base times height, so it's 1/2 base is 8. Height is 4 root 3. Half of 4, or half of 8 is 4. 4 times 4 is 16, so 16 root 3. I plug 16 root 3 into my calculator and I get 27.71. And that's the hard part of this problem. We have one last step, which is going to be to find the segment area. And the segment area is equal to the sector area minus the triangle area. So my sector area I found to be 33.51 minus the triangle area is 27.71 equals, and when I do that I get a final answer of 5.8. And just make sure you have the correct units. We were talking about centimeters here, and this is area, so I'm going to have centimeters squared. And that is my final answer for that. Okay, so I'm now going to look at number 20. It says, what is the area of the shaded segment? Same thing, it's just turned. So if that helps you, just keeping your paper like this and doing it that way, that's totally fine. I'm just going to draw it out as if it was up, or if it was turned, just to give you a little bit of a clearer view. But let's start with step 1. So step 1 is going to be the secant area. And that here is going to be equal to, that is a 90-degree angle, so that's 90. So 90 times pi r squared, so pi, my radius here is 10, so it's 10 squared over 360. I'm going to put that in my calculator. It ended up being 9,000 pi over 360, which is equal to 78.54. So that's my first step done. Moving on to the second step, as we said before, it's definitely our harder step. So, looking at this, it's the triangle area that we want, which is equal to 1/2 base height. I'm going to start by drawing out this triangle. It ends up being just like this, where we want this part, which is our height, and this part, which is our base. So looking at that, I'm also going to redraw it over here. These are both 10. This is a 90-degree angle. Now the top angle up here is 90. So this is 90. So each of them are going to be 45 because I split it in half. Yet again, I'm just focusing on the left side of this triangle, which is really this part of it. Okay? So if this is 45, that's 90. This has to be 45 also. I'm just going to redraw it again. I have 45, 45, 10. I'm going to label X and Y. The really cool thing about this is we really only have to find one, since we know they are equal to each other. Since it's a 45, 45, 90 triangle, my equation is the hypotenuse equals square root of 2 times leg. My hypotenuse is 10. Equals square root of 2 times leg, divide by square root of 2, divide by square root of 2, I get x equals 10 divided by the square root of 2. Rational Rabbit would not be thrilled if we didn't rationalize this, so that's what I'm going to do. 2 goes into 10 5 times, so it's 5 root 2. Okay? So this here is 5 root 2. This here is 5 root 2. So my height is 5 root 2. If this is 5 root 2 and this is 5 root 2, think of it this way. I have 5 root 2's and I have to add it to 5 root 2's. So how much do you have total? You have 10 root 2's. So that's my base. Now I'm going to go in and solve for my area of my triangle. I have 1/2 base is going to be 10 root 2 times 5 root 2. Plug that in, it ends up being 50 when you multiply them. So looking at that, that is my second answer. Third step is the segment area, and I'm just subtracting the 2. So it's 78.54 minus 50 equals, and in this case we get 28.54, and I'm going to throw feet squared at the end there. So that is my final answer there. Okay, last one of these. What we have is, this one ends up being a little bit of a different setup. It ends up being the Sokotowa one. So let's look at what we got so far. It says, what is the area of the shaded region? I look, well, here, that's going to just be the segment, okay? So if this is 144 and that's its intercepted arc, its central angle is equal to the intercepted arc, okay? So it's just the same thing except 144 in the middle, okay? So we're going to be making that line, the right angle, splitting it. Let's start with this sector area. Sector area is equal to, my degree is 144 times pi, my radius is 5, r squared over 360 equals, and when I do that, I get 3,600 pi over 360 equals 31.42. So already done the first part of this. We're going to move on to the second part, the triangle part. So we're going to have the triangle area equals 1/2 base times height. So I have this. I'm going to turn it. It's going to end up being cut by a perpendicular bisector. Height is here. This is the base. And I'm just going to redraw this triangle also here. The two sides, the radii are going to be 5. Okay, so this is the cool part. We split 144 in half, we get 72. So I have 72 on both of them, but here's the thing, we don't have a 72, 72, 90 triangle. This is gonna have to use Sokotowa. So I'm gonna focus on that left triangle. It doesn't matter which one, I always do this one, consistent. So we have 72 degrees here. I have 5. I'm going to throw X and Y here. Mark my angle. This is its opposite. This is its hypotenuse, leaving this with its adjacent. Let's solve for X first. So I'm kind of just going to cover this up. I have 72 opposite and hypotenuse, so OH, so that's sine. So I have sine of 72 degrees equals so it's X over 5. Okay, multiply each side by 5 to get the 5 to the other side. I have 5 times sine of 72 degrees equals X, okay? I have x equals 4.76. Okay, so I'm gonna fill that in right here. This is 4.70 or 4.76. This is 4.76. The whole thing there is 9.52. And I'm actually gonna throw that over here while I'm at it. 9.52. Okay, so let's look at y now. I'm gonna cover this up. I have adjacent and I have hypotenuse, so 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 cosine. So cosine of 72 degrees equals so it's y over 5. Multiply each side by 5. I get y equals 5 times cosine of 72. Y equals, and we get 1.55. That's over here, so that is the height. So I'm gonna go over to the height and fill in 1.55. Now I can just finish off the triangle area by plugging it in. 1/2. The base is 9.52. The height is 1.55. Equals 7.378. Okay, last part over here is segment area, and I'm gonna subtract the 2. I have 31.42 minus 7.378 equals, and that leaves me with 24.04. I'm gonna throw meters squared on there, and that's it. It's a hard section. Just keep trying them. I put 2 of them on the homework. Send me a reminder if you need anything. Other than that, good luck.